Today I'm going to talk to you about these. This is a Raspberry Pi. It's been a computer that's been around for probably roughly about 10 years. This is the latest model. It's a 4B. You can actually find these at Target in the electronics section and run for about $49. What they do contain, though, if you do get them there, is just the motherboard. We're going to be using these this year for projects such as virtual private networks, VPN. I'm going to show you how a media server works. I'm also going to show you how you can actually build your own cloud server at home using Nextcloud with a similar device as well. We actually have two of these in the house. Now, this has the nice case on it. This is a case that I actually tested for a company, and I'm going to kind of put the name up on what the company is because I can't pronounce it. But I did do a test on it. You actually see that how it looks. It is a very small computer. It is about the size of a pack, roughly about the size of a pack of cigarettes, and it has pretty much the same components that your computer has. These are considered ARM processors. They have a 64-bit 8-core processor in them. They come in different memory configurations, all the way up from 1 gig to 8 gig. The 8 gigabyte model just came out about a month or two ago. This one is a 4 gigabyte model that's currently using, and this particular device is used for VPN as well as the media server. Now there's going to be two different operating systems that I'm going to show you with these devices in this video series. One is going to be the Raspbian operating system that comes with the device, and then there's also going to be Ubuntu, which we're going to use for the Nextcloud server system. These are Linux computers. These are not Windows computers. They are very low with memory resources that they use. They do have a lot of benefits in terms of security. A lot of people do believe that there's a lot more security to these devices than other devices out there. And Linux isn't anything new. It is a derivative of the Unix operating system. And during the 80s, when I was getting into the computer business, we were doing a lot with Xenix, which Xenix was actually became Linux. And it was Microsoft's idea to take over the Unix operating system from the phone company and use it with a lot of the x86 devices, the 286s and 386s and the 486s. And they were actually used to run a lot of the dumb terminals that we did use on a couple of offices that I worked with back in the Seattle area during the 80s. But as Windows came around, most of that system died off pretty quickly.
As Windows took off during the 1990s, there were several companies that were working on taking the Xenix and the Unix platform and converting it with a graphical user interface to create Linux that we use today. There are a handful of some of the companies that you'll see. Next, when Steve Jobs left Apple, certainly a lot of what he did with Linux is in the Apple operating systems. Now, Sun was another big one. They used a lot of their stuff with Java, MySQL Server, and developed a Linux system as well. And a lot of those assets are now in the hands of Oracle. Red Hat was another big one. It was a paid operating system to use. That's now in the hands of IBM. Ubuntu runs an open source one. They also have a paid one, but it is free, and that is one we're going to be using. And Raspbian, which is another open source version that is of no charge that comes with the Raspbian system. That's another version that we're going to be using with this project as well. So I'm going to go over the parts that are used on a Raspberry Pi so that you're familiar with what these devices contain. Now, there are two ways to purchase the Raspberry Pi. One is strictly by the motherboard. The other way is the kit. If this is your first Raspberry Pi, it's a good idea to get the kit. Not only will you get the motherboard, you'll get the heat sinks, the memory card reader, the power supply, and the case. If you do decide to buy the motherboard and you decide later to get everything else for it, I don't know if there's really much of a savings to it or not, but if you look around on eBay, there's a possibility that there may be. If you have any questions about it too, you can always email me as well. Since our examples are working with the cases, I'm going to show what it all looks like once it's all fit and put together. Now, on top of the case, you will see a fan. Now, these fans run on two different power options. One is 3 volt, one is 5 volt. If you use the 3 volt power supply option, it's going to run a lot quieter than the 5 volt. Sometimes the 5 volt is used for video games and people that overclock the Raspberry Pis to do graphic intense work or other options. We're not recommending that in this video series to do that, because it can ruin the board, and if you do have a warning, yes, you can get a warning with these devices, it will damage that as well. But for what we're doing, the 3 volt option is fine. So in the front of the Raspberry Pi with the case on, you're going to notice there's 4 ports in the front. One is for the power supply. The other 2 are 2 micro HDMI ports. You can support dual monitor on here. Now with the micro HDMI ports, there is a little bit of a limitation than what the standard port has. So sometimes they're not going to be able to support audio or power to them, or just a video signal. And which is the reason why there is an audio mic port with this device as well. Now on one side of the Raspberry Pi board, you're also going to notice several USB network ports. There's 2 USB 2 ports, 2 USB 3 ports. Those we're going to be using for USB 3 hard drives, and a 1 gigabit Ethernet port. Now this board also includes Wi-Fi and Bluetooth, and those we will discuss in the next set of slides. Now the next section is going to go over the motherboard and show you where all the parts are. Obviously this is going to be important because this is where all the heat sinks that you get with the kit go. So the first chip, that's the important one on here, is the processor. Again, it is a 64-bit 8-core or octa-core processor known as an ARM. The next chip in the upper left corner is the RAM, or the random access memory. And there's different combinations. They can run all the way from 1 gig up to 8 gigabytes for this particular motherboard. To the right of the processor is the video chip, and it does run HDMI, and I also understand it does do 4K. The rest of the remaining chips on the right of the video are the chips that control the Ethernet, the Wi-Fi, and the Bluetooth. Yes, these devices do have Bluetooth and Wi-Fi signals that you can use as well. Now, the last piece of hardware I'm going to cover on the motherboard is known as the GPIO. Those are those pins that are on the top part of the motherboard. There's only 2 things that they're being used for right now. One is the fan, and one is also being used as a clock that we're using on the cloud computer. The reason is that because there was some money that was saved when they made these cards, so there isn't a battery-backed clock device on here, but you'll see in the some of the other videos a Raspberry Pi that has one that you can get very reasonable on Amazon that can work to serve that purpose. Now the power for these devices is a USB Type-C cord, very similar to the ones you use with most of the Android devices that are on the market today. There is a bit of a difference though in how the power cord should be that may not apply to your phone. The one that works for these particular computers must have 5.1 volts with a minimum of 3000 milliamps. If you get the kits on Amazon with the board, you'll have the correct cord to run it. Some of the cases, if you buy the case separate, there's also one that you can purchase as well. Anything less than this cord will cause an undercurrent. That means if you're running the 5 volt ones that are typical because they do have the same power that a USB on a computer has, it may not have enough power to run the computer. An increase in amps can damage the computer, so it's a good idea to stick with these specs. Next thing is the heat sinks. Now there's some cases that have a built-in heat sink into them, and there are some cases that have heat sinks that come with them. And if you look in the diagram closely, those little gold specks on there, those are the heat sinks that we're using for this particular device. And now there are a lot of nice things about these, and it does keep the computer cool, especially when you use them with the fan, and I certainly encourage them to be used. One nice thing about them is that you don't need the thermal compound like you use on the Intels and the AMD chips. They're all self-adhesive, so that is very sweet and less mess. The next thing I'm going to talk about is the memory cards for the device. This is something that is new to run a computer on. So keep that in mind with using this, because these were not really designed for that application. So for this particular device, we're using a Class 10 micro SD memory card. Now, I do like SanDisk Ultras. They're great. I've used them for years. SanDisk has really been about the major brand that I've used for any of my memory cards in the last 20 years since they've been out. And they're very reliable. They have a lifetime warranty. And they are very fast. Now, for this particular project, the minimum that you should use for a memory card is 32 gigabyte. The maximum size being 512 gigabyte. Now, I know that there are memory cards out there that are bigger than 512 gigabytes. They should not be used for this computer. The reason is that, again, they were not designed for it to be running a computer, and they will run very slow, and they are not very reliable. Now, I'm not a big fan of the 1 terabyte and the 2 terabyte memory cards that SanDisk is producing for these, and believe me, I could come out with a whole nother video about what's wrong with people that are using those. But especially if you don't have a backup device when you do use them. So just keep that in mind when you get these, because if you're using those cards, for as expensive they are, you're wasting your money and you're wasting your time. Now, for these devices, you're also going to need a USB card reader. Now, the kits do come with, most of the kits do come with them, but if you do have one that works for these micro SD cards for that memory size, great. Be careful of that, because there are different ones out there that handle ultra capacity, extra capacity, and you got to make sure they're rated the same. It's always a good idea too to have a backup memory card, because with these machines it is easy to clone the card to this device if there's anything that goes wrong with it. And there are a few examples that may be covered in the video series to show that is being done. So that's another reason why you want to stay away from these large expensive memory cards, because if you have a 512 gigabyte memory card, it's best to buy 2 and not just 1. Now, if you have any questions about the Raspberry Pis, Raspberry Pi does have a website, raspberrypi.org. It is a nonprofit organization that runs this project, and it's a great project. It's been around for many years, and I hope you enjoy what I've covered in this video. And if you do have any questions about that, about the video and the material covered, you can certainly reach me by email on the website timbabcock.net as well. Thank you, and you have a good day.